Hey everybody, today we are going to solve 2x2 systems of equations. That means 2 equations and 2 variables. We will solve 6 of these systems together like this, and then we will do 2 more that are word problems, so we'll do some application. Okay, so here on number 1, we can eliminate these x's because 2x minus 2x is 0, so those cancel. So we have 2y plus 5y, which is 7y, and 2 plus 61 is 63. So we'll divide both sides by 7, and 63 divided by 7 is 9. So we have y equals 9, and then we can substitute that into one of the 2 original equations. I'll go with the top one here, so 2x plus 2 times 9 equals 2. So that's 2x plus 18 is 2. Minus 18. And I get 2x equals negative 16. And divide by 2. And I get x equals negative 8. Number 2 is not quite as simple because here I was able just to eliminate what was there. On this one, nothing is really set up to eliminate. So what I'm going to do here is multiply this top equation by negative 4. And then I'll rewrite that down here. Negative 4 times negative x is positive 4x, and now those are ready to eliminate. Negative 4 times negative y is positive 4y, and negative 4 times 7 is negative 28. Now I can eliminate the x's. So I have negative 5y plus 4y, that's negative 1y, equals, and then 39 minus 28 is 11. So if negative y equals 11, then positive y equals negative 11. So there's my value of y. Now I'll plug that into the top equation up here. So I have negative x minus negative 11 equals 7. So that's negative x plus 11 minus negative is plus equals 7. And I'll subtract 11. So I get negative x equals, and 7 minus 11 is negative 4. So if negative x equals negative 4, then positive x equals positive 4. Number 3, I have x minus 9y, then I have negative x plus 2y, so nothing is really set up to eliminate. So I will multiply this top equation by 9. And bring that down here. So 9 times x is 9x. Now I have a negative 9x and a positive 9x, so those are set to eliminate. And then here I get negative 81y. And then 9 times 64. Okay, so I'll bring in a calculator for this one. So 9 times 64. Try that again. 9 times 64 is 576. So now the x's will eliminate. I have 2y minus 81y. 2 minus 81 is negative 79. So I have negative 79y. And then negative 102 plus 576 is 474. And divided by negative 79, we have negative 6. So y equals negative 6. Okay, now let's plug that into the top equation. It does not matter which equation I choose, I'm just choosing the top. So x minus 9 times negative 6 equals 64. Negative 9 times negative 6 is positive 54. And when I subtract 54, I'll get x by itself. And I get x is 10. Number 4, I have a couple different options. I could eliminate these x's by multiplying, say, the top by 3 and the bottom by -2, or I could multiply this one down here, and this is what I'm going to choose to do, is multiply this by -5, and that will eliminate the y's. So I'll rewrite that right underneath, so I have -15x plus 5y equals 55. Okay, now I don't have these written right over the top of each other this time, so I will put them together right over here. So 2x minus 15x is -13x. -5y and +5y eliminate each other, and -29 plus 55 is 26. So now I can divide by -13, and I get x is -2. And let's substitute that into the bottom one here. So I have 3 times -2 minus y equals -11. So that's -6 minus y equals -11. And I can add 6, and I'll have to move that over here. So I get -y equals -5, which means positive y equals +5. Okay, now I'm going to skip a couple here and go down to 8 and then 9. Okay, so on 8, nothing is really set up to eliminate, but I could multiply this one here by 6 and this one by 5 and rewrite it as -30x minus 30y equals, and then 6 times -15 is -90, and then 30x plus 30y equals 5 times 18 is +90. Now in this case, when I start to eliminate, the x's will eliminate and the y's will eliminate, leaving me with 0 on the left side, and then -90 and +90 also eliminate, so I get 0 on the right side. So I get 0 equals 0. And that is a true statement. That leaves me with infinitely many solutions. So this time there's not just a single solution for x and y, there is an infinite number of possible solutions for x and y. Okay, then number 9. So this time I will multiply this one here by -8. So I get 8x plus 8y equals, and then -8 times -63 is 504. And here I can eliminate the x's and the y's and get 0 equals, and that would be equals 549. Now this time, I don't get a true statement. 0 does not equal 549. This time there is no solution. Okay, now let's do a couple of application problems here. To win a basketball game, one team scored 98 points. They made a total of 42 two-pointers and three-pointers. How many of the baskets were worth 2 and how many were three-pointers? Okay, so two-pointers and three-pointers both start with a T, so let's go to the second letter. We'll call two-pointers W, three-pointers 3, and in this case, two-pointers plus three-pointers were a total of 42 baskets made. Okay, now for every two-pointer, you get 2 points. So 2 times W plus 3 times H, because you get 3 for every three-pointer, led to a total score of 98 points. So now we'll solve this system of equations. So let's multiply this one here by -2 and bring it down here. So we have -2W minus 2H equals -84. And the W's cancel. Two-pointers cancel, so we have 3H minus 2H, which is H. And 98 minus 84 is 14. So that means this team made 14 threes. Okay, now let's substitute that here. We know that they made a total of 42 baskets. We don't know how many were 2-pointers, but we know 14 of them were 3-pointers. And we can subtract 14. Okay, so 42 minus 14 is 28. So we know that the team made 14 threes and 28 twos. Tickets to a fair cost $4 for children and $14 for adults. On Thursday, 188 people entered the fair. So that means children plus adults on that day totaled 188 people. They collected $1,672. So at $4 for every child plus $14 for every adult, they ended up with a total of $1,672. How many were children? How many were adults? So let's multiply this one by -4 and bring it down here. So we get -4c minus 4a equals -4 times 188 is -752. Now, children are eliminated in this equation. 14a minus 4a is 10a, and 1672 minus 752 is 920. And I can divide by 10, and 920 divided by 10 is 92. So, on that day, there were 92 adults. Now we have to find out how many were children. Okay, so we can plug that 92 into this original equation. Children plus adults was 188, so children plus 92 is 188. And we will subtract 92 from both sides. 188 minus 92 is 96. So there were 92 children, there are 92 adults and 96 children at the fair on Thursday.